So bonjour everybody. Welcome to this new edition of the ETP4HPC webinar series. We welcome you very much today for this new episode, which is about urgent computing. And Manolis or Mark, could you confirm that you can see my screen?
Yes, I do see your screen, webinar number 17.
Very good. Thank you very much. Thank you very much. So again, sorry for this mess a little bit this morning, but we are confident that this may not impact more the rest of the seminar. So before we start really kick off, we will inform you that this webinar is recorded and we will share the link with you on Monday. And this webinar is in listen-only mode, but you have, of course, the control panel to ask questions and to download the handouts. And we plan for a presentation of roughly 20 to 30 minutes, which leaves us enough time during the end of the webinar to have an exhaustive Q&A session. So please do not hesitate, do not be shy to post your questions. We will share these questions then later with the panelists and answer them after their presentation. Today's topic is HPC for urgent decision making. This has given rise to a white paper which has been published very recently on our webpage. You can find it also, this paper and much more white papers, on our ETP4HPC webpage. And today we welcome with ours Manolis, Mark, Dirk, and Hans Christian, who are the main authors of this paper and who will give us some more insights about what, according to them, is the main topics related for urgent decision making. With this, so as I said, this is the full agenda. This is the short introduction done by me, Maike Gillo, today, and a presentation of our authors, which is then followed by a Q&A session. So without further ado, I hand over to Manolis for kicking off his presentation.
Well, thank you for the introduction. Let me get started. Let's go.
Very good, perfect.
So far, so good. So
yeah.
Again, I would like to thank the ETP office for setting up this event so that we can have a discussion started on this topic of applying HPC in a decision-making setting. The particular topic that I would like to explore a bit more today is about the challenges related to resource management. In the decision-making context, we would be asked to have more flexible and responsive resource management techniques, and this is a bit of a challenge. So again, just to set the context for why we did a paper, there is this activity of ETP4HPC around the development of a strategic research agenda, which in a sense it's a roadmap exercise for European HPC technology research. And for this particular iteration, which is iteration number 5, the ETP group decided to do a series of white papers that tackle technical issues that are very relevant to HPC, but perhaps are a bit more specific to a certain technology aspects or certain types of applying the technology. So as far as I know, there is a set of 8 published papers at this point, and today's session is about one of them, the one about urgent decision making. And you can find it on the website of ETP4HPC, but also on via the Zenodo Open Access repository. So the idea is that we would like to explore how to use the full range of HPC system capabilities in a decision-making context so that we gain insights about developing situations and support decision makers in assessing what the data show them, and likewise what actions they need to plan and orchestrate. So there is quite a lot of let's say interest in this type of capability, but perhaps the HPC aspect deserves a bit more of an exploration. We start by considering some use cases where there is this concept of incident response, and I'll bring up some examples from the Destination Earth initiative. These are relevant also to other broad-scale initiatives within Europe. And we will see what are the technical implications of addressing this type of use cases. So again, trying to provide some context for the discussion. So I'm using a diagram provided by the Destination Earth initiative. This is, again, a broad scope initiative by the European Union, and involves activities in various sectors that might motivate the work around decision-making support. So there's the discussion about climate change. There is a discussion about handling of natural disasters and the associated risk management around them, as well as topics related to energy and precision agriculture, etc. Now, in these contexts, we see some examples where there is a need for an urgent response, so a response within a bounded time interval, a rapid response, but also a predictable time-bounded response to prevent catastrophic events or catastrophic consequences for human injury or loss of life, damage to significant infrastructure, etc. It might be that the response is just a management of a disaster relief effort. And the examples would be, again, reaction to disasters, events related to weather, space weather as well. So further to that, there are cases where the emphasis would be on predictable response. So not necessarily real time, but again, within a predictable time window. So this type of let's say use cases, an example would be climate modeling using sophisticated Earth simulation models, would involve the rapid analysis of complex systems. And as we gain processing and data storage capabilities, we can hope for a higher resolution, both in the time domain and in the spatial domain. So this gives us more accurate and let's say more fine-grained predictions that would be valuable for guiding actions both in the short term but also in the midterm. So for these type of things, I mean, it's kind of intuitive to expect that HPC has a role, but it's not just reducing the time to solution. The claim made out in this white paper that I'm presenting today is that really it's the only viable approach to process large data sets of high complexity and within the time constraints that I outlined above, going through the use cases. So let's go into some more detail about these ideas. So again, my background is on systems programming, systems management, etc. So the presentation today is more focused on this aspect. So an observation is that, okay, we're talking about events that are not exactly predictable, and we need to have a fast response to them. And how does this compare with the common access and usage policies of HPC centers? Well, in a nutshell, they don't fit quite well. The current predominant model of using an HPC center is to rely on relatively long-term arrangements. We use resources on an exclusive basis based on a time schedule. And there are well-established but usually time-consuming policies for granting the necessary level of access. And further to that, the majority of users are experts in some scientific domain, might be computing system experts as well. Well, in a decision support scenario, and especially in an urgent decision support scenario, we would need to serve the needs of incident response teams that would need to initiate complex processing on short notice and actually modify the the set of resources or augment the set of resources based on their judgment on how a complex situation evolves over time. So there is this idea of a workflow. I think that is quite relevant here. There is quite a lot of research. Actually, there are tools and actually products that would support HPC workflows. Such workflows would rely heavily on data assets and data-driven processes, but it might be that the particulars of a decision support scenario do not map well with the common practice within a supercomputing center. But furthermore, the people involved in an incident response team are not necessarily the regular set of users of our HPC centers. Still, they need to initiate workflows, interact with them based on their understanding of a situation. And by the way, the resources that they use are quite significant. They are not, let's say, a small fraction of the available resources. It might be that they need intense use of significant resources on short notice. So this type of arrangement doesn't quite feel well the expected users pattern around which HPC centers are structured today. And today I would like to point out also some technical implications, particularly related to the system software support for the HPC center, and how we can establish more flexible usage modes and be able to combine the available resources. Now an HPC center today provides, of course, compute resources, but also significant storage resources, and increasingly also support for analytics, AI, and ML style processing, right? And we would like to see how to make the best use of these resources in a slightly different context than what is the common practice. Now, I'll try to outline an abstract support flow, decision support flow, that relies on model-based simulation and data analysis, so that we get a better feeling of where these, let's say, technical challenges lie. So let me go through this diagram with you. So we need to have both processing and data assets. That's fine. So simulation, online, various modes of that, models that have been developed, elaborated, and tuned, data and code assets available in some sort of repository, and perhaps in a flow of data coming from the outside in the form of files or streams. Perhaps they need some pre-processing, such as cleanup and let's say format transformations, etc., to make them usable by the existing codes. And there is some sort of user interface that is where the domain experts and the incident response team will be interacting with. Now, the focus of this white paper and talk is this area, the combined use of simulation and data analysis with existing code and data assets. And I'm just pointing out that the development of the models and elaboration and tuning is a major endeavor itself. Relevant technology would be what we call digital twins. There have been presentations by ETP4HPC around that topic. And the idea would be that we are using these models that have been developed, let's say, offline, in supporting an online problem solving challenge. Okay. Now, recapping what I said earlier, it seems that a critical capability that we need to have, and we don't really have it today, but we can build on what we have and perhaps augment, is to be able to intervene and modify schedules of batch style processing. So be able to add resources or change the sequence of processing steps, etc. And by the way, we need to engage the resources as we need them. So in a more ad hoc manner, rather than the, let's say, regular predetermined batch style processing mode that we are more familiar now. So this type of capability would be essential for us to be able to generate actionable results. Actionable results is really what incident response is all about. You need to have an understanding of the situation and make a the decision on about follow-up steps, actions that have actually a bearing in the physical world. Okay, the time windows are rather tight, and by the way, we cannot really predict when these events will occur. So that brings me to a practical issue. Should we just maintain a static setup, a set of resources dedicated to handling this type of situation? Well, it makes operational sense. Examples of that would be like operational weather forecasting centers. So a prominent example would be Japan's earthquake early warning system and incident response coordination. Now, there are, beyond the operational aspect, there are all, however, some efficiency and effectiveness concerns. Setting up dedicated resources for each of the domains might not be economically viable. Remember, we are talking about expensive and quite substantial resources. And there is usually some sort of discussion about budgets and justifying a major capital investment in creating the infrastructure, providing the resources, etc. Now, in the particular environment that we are talking about, the computations would be taking place rarely. And by the way, the resources have to be substantial. So this would favor a sharing arrangement, so using the existing infrastructure, but this carries its own set of caveats. Okay, one, let's say, caveat would be like, if I'm dedicating resources for each type of possible event, then I might be in a situation where I need to pretty much replicate the infrastructure with significant cost. And perhaps I don't have enough capacity in the end to handle a more complex situation. So it seems from this point of view that is mostly from the economics point of view to use time on existing, large-scale systems at the international, national, or regional level, and perhaps add to them the capability to use resources that are outside their own boundaries. So this points to an idea of federating the available resources under some, let's say, initial arrangements, and be able to deploy them in a coordinated manner when the need arises. So this, again, pushes the boundary in terms of being flexible on how to request resources, how to engage them in the necessary processing based on the flow that I outlined earlier, and be to some extent scalable in the sense that, okay, I can start with a relatively small set of resources, perhaps on a regional HPC center, and perhaps engage further resources outside the boundaries of that regional center based on how the situation evolves. So again, flexibility and responsive resource management, why don't we have it already? Well, we would like to have short notice access, and as I said earlier, there are now some complications, especially if I'm going outside the boundaries of a single center. The workflows will be processing large data sets, and they might have needs for more dynamic, let's say, evolution. And this carries both technical and organizational challenges, right? The engagement of resources, allocation, and scheduling is more dynamic now. In a sense, we need to augment the capability to react to urgent demands rather than just schedule a regular processing based on our understanding of an environment. A little detail that I will come back to later is that a lot of the processing power comes from accelerators. Accelerators are a bit awkward in this type of environment, and I will explain a bit more. There is an issue of coordinating the resource managers. So we would like to have elasticity, start with a few resources, add to them based on needs. There are challenges related to authentication and authorization. We need to manage sets of credentials that are acceptable outside a single processing site. And likewise, we need to track resources and monitor their usage. Now, a key point here is that we now anticipate more interaction with facilities or services that are external to the particular HPC center. Likewise, outside, let's say, the cluster level, management that we are more accustomed to. Workflows engage a lot of data, so there has to be particular emphasis on how to acquire the data, make them usable. And to make them usable, it might be that we need to transfer them onto the place of processing. And one of the particular techniques that we might need to consider is to stage the data, actually anticipate that they will be needed, move them to node local storage, for example, and make it available for later stages of processing. Now, overall, there is an increased need for interactive use. Well, it's not like using a desktop, of course, but we now see the need to actually be able to observe the progress of sets of simulations, perhaps be able to intervene in near real time and steer, cancel some simulations, launch new ones. Simulations might be in groups, ensembles, to explore a parameter space or what if type of analysis of scenarios. And also a very practical aspect is that we need to be able to preempt existing computations. If we need to free up resources in a reasonable time frame, then we need to be able to intervene and free up these resources for the urgent processing. Now, it might be that we just dispose of these jobs, but it might be that we need to keep state and allow these jobs to be runnable again later from a reasonably recent checkpoint. So this dynamic preemption capability seems to be actually quite hard to achieve. And I will spend some time later talking a bit more about that. Now, I will try to outline a possible architecture, just actually highlighting building blocks for a decision support environment. Starting from the top going down, there has to be a decision support user interface. It might be in the form of a dashboard. Data might be laid out on top of, as layers on top of maps in the form of a geographic information system. Notebooks might be relevant here, ways to combine code invocations with data. And likewise, a lot of visualization is needed to present complex information in, let's say, usable format. Now, this interface has to control both data and processing. So starting from the data on the right-hand side, well, we assume that there has to be an infrastructure for data management, data storage, and likewise efficient interfaces for data access. The data assets, as I said earlier, might be also external to the processing side, not just local. Likewise, the codes to be invoked might be local or available from an external source. For the processing side, which is actually the focus, more focus of this talk today, we need to handle the workflows, not just single invocations of some code, but also a sequencing of steps for both simulation and data processing. We need to be able to actively manage the simulation. Remember this comment about possible interactive use of the compute resources. We might need to be able to handle coupled simulations where the output of one processing stage becomes input for further stages. We might have ensembles of models trying to compute possible outcomes, starting with different models, perhaps getting more detail on particular aspects of a phenomenon that we are trying to observe and perhaps predict the outcomes of. And likewise, access to available models and prior results. It seems important to keep results even in this type of environment. Keep a track of what has been processed, what has been, let's say, already computed. And by the way, there is the particulars of dynamic execution. I hinted to this just before. We have processing that can be time-based, so initiated at regular time intervals or at scheduled points in time. It might be that some processing is initiated based on the availability of data, so that would be data-driven execution. And in the process, we need to enforce priorities. If we are sharing the infrastructure with, let's say, regular processing jobs, it might be that in the case of an event, we need to preempt these, and preemption itself can be quite complex and quite, let's say, hard to, complex to handle, and also with repercussions for the infrastructure. And eventually we'll be interacting with the code assets and the data assets. And if we also take the path of a federated facility, then we need an interface that allows us to have job control using appropriate credentials. And this can be, again, challenging to achieve. There is particular work within ETP4HPC. There is actually a dedicated white paper on this topic of federation. And I think it's quite relevant to this discussion. Now, some details about what it would take to have a dynamic execution environment. Well, I mentioned preemption again, based on priorities. Preemption allows us to achieve rapid resource availability. Another way to say this is that we minimize the resource occupation by the jobs that are being preempted. Well, the usual approach of just reserving resources well in advance is not adequate in our case. That's why we rely on preemption. We need to provision a complete workflow, and the workflow is dynamic and quite heavy in resource consumption when an event occurs. It's not just, it might not be as effective to just assign resources on a job-by-job basis, which is the common practice now. And in the process, again, there's the heavy focus on data and simulation management. Okay, and now let's say the beneficiaries are the decision makers, which can be public authorities, also domain experts, etc. So complex manipulation of data and code, handling a dynamic schedule, and by the way, it might be necessary to expose controls for this type of actions to people that are not necessarily system experts, computing system experts. And this idea of adaptation, that perhaps certain triggers based on time specification or availability of data change the set of resources that need to be engaged, and likewise the flow of processing steps. I mentioned the example of triggers, but perhaps it could be intervention once we try to steer the computation based on what we have established so far, and likewise if we want to prioritize exploring particular options. So preemptive scheduling seems to be an important capability, and it's a bit outside the current practice, and it pushes us also to develop and deploy new technologies. I'm highlighting two aspects there. Improvements in how we checkpoint the running applications. Remember that we are relying on preemption to release resources, but perhaps we should also improve the way to capture the state of running applications and allow them a clean start once the situation improves. Now, if I have accelerators, then this becomes a bit more complex, because accelerators are carrying a lot of the compute load in current practice, especially for simulation style processing. But they are not very, let's say, comfortable to use in a checkpointing situation. Further to that, the checkpointing itself pushes a lot the capabilities of interconnect storage, and this is because once we have a preemption event in this setting, we will be basically generating a storm of requests, a storm of traffic for the interconnect and the storage infrastructure, etc., to just capture the checkpoint and likewise load up the initial state for the urgent decision support processing. So at least two areas where we might need to pay more attention. Now, again, I'll highlight the possibility that the CPU and storage resources needed for the decision support processing are not likely to be co-located. So this means that we need to improve our data management and caching services, and by the way, be interoperable with storage and management architectures, for example, a data lake architecture, and be able to interact with large repositories, both for reference data and likewise also to capture our outputs and transform the data. So that pushes again the performance envelope for parallel file systems and other storage services, but also pushes us, I think, to explore techniques of data staging, where perhaps the availability of local storage resources is important. Now, again, this is not necessarily the common configuration of HPC compute nodes today. They usually rely on storage available over a network, not necessarily a lot of node local storage, but I think this type of situation warrants revising these decisions. Mentioning this just in passing, a lot of cybersecurity concerns, and I'm just highlighting the aspect of data integrity. We rely heavily on the data and the quality and let's say provenance of the data that we process in our decision-making workflow. So we need to have in place techniques and infrastructure to validate provenance and likewise increase the trust level in what we are computing and what we are producing. Now, the white paper provides a set of recommendations. I'm just going very briefly through them. Advances in the state of the art needed for securing short notice access to resources that might be federated. System software has to address a lot of challenges by having to support more flexible and dynamic resource allocation and scheduling. Workflows are now more data intensive in this setting, so perhaps the idea of data staging might be important to explore more. And overall, more interactive use, that might involve direct intervention in the form of steering, but also the very practical aspect of releasing resources via job preemption. To get to the point where we can efficiently develop this type of workflows for decision support, I think that we should anticipate also enhancements and extensions to existing HPC programming models and APIs, find ways to express more complex units of work, for example, samples, data staging, etc. There are quite a few tools, most of them domain specific, that allow you to handle, for example, samples. But I think we need to do a bit more to put them in a more, let's say, usable context for this type of decision support and the complexities arising from a more dynamic evolution of the execution. Remember also this extra challenge of having to interact with facilities external to the HPC system. Interactivity in the way that I explained before, be able to integrate digital twins as they provide predictive models. So these are quite important. One of the reasons is that we can have shortcuts to save time when a particular situation is evolving. Perhaps we can identify scenario that we have processed before, and this allows us to respond even further, or at least have a first order approximation of what is going on and perhaps rule out certain possibilities or prioritize others. So if a good integration of a digital twin environment, I think, is quite important. And it was part of the abstract model that I presented earlier. And on the very, let's say, hands-on part of things, I think we are lacking now reference system architectures and interoperability standards. And I think that would be a good step forward anyway for complex HPC environments, and particularly for urgent decision-making tasks. In conclusion, and I think I'm almost exhausting my time, by identifying the need to provide prompt access to decision makers, we are unveiling, we are pushing forward the envelope for technical capabilities, but also we are exposing some let's say, limitations in the common use and access policies of the HPC centers. I'm saying this, I'm not saying this entirely in a negative light. I'm just saying that if we accept that this type of processing has to be handled by the existing HPC centers, then we need to change the policies as well, and likewise improve the technical infrastructure. Okay, I'm highlighting the aspect of scheduling resources in reaction to urgent demands rather than in a schedule that is, let's say, well established and can be reviewed, and it's not often changing. And these are aspects that we need to be aware of. Now, details, of course, available in our paper, available from the ETP4HPC site, but also via the Zenode Open Access repository. The talk will be followed by a panel. The authors, I think almost all of the authors are available. Mark, Dirk, and Hans Christian and myself are available. We are supported by our respective organizations, and I would again thank ETP4HPC for giving us the opportunity, and of course all of you attending, putting time in this presentation. And I'm looking forward to your questions and likewise your input, especially during the panel session. That will be all from my side.
Thank you very much, Manolis. Thank you to all of you for this paper, and thank you for this presentation. Very interesting. Perhaps I can just kick off with one question before going to the questions from the audience. I was wondering, so I think that the COVID pandemic was sort of a good example on when urgent computing can be needed to some degree. Do you have seen in the past years, let's say in the last 2 years, some strong development in the HPC ecosystem towards more urgent computing, to more work, towards more capabilities for doing urgent computing?
I think what you brought up is actually a very good example. So people have been talking about the need to, for example, predict the spread of a disease as COVID, and likewise to orchestrate response. Frankly, I've not seen so much of a, let's say, systematic approach to that. I've seen, on the other hand, I've seen, let's say, urgent response to that, and I can bring up 2 examples. So, for example, the PRACE organization in Europe prioritized access for epidemiology studies, and I think that was a great resource to have. And likewise, in Japan, they did a very interesting study of the spread of actually micromolecules in various, let's say, simulated environments, and they dedicated. And there they took, I think, that the path of dedicating significant resources to the task. Now, what we're talking here is there is an academic community around that. There are some events. Actually, there is a workshop. There are some workshops in events like I don't know, supercomputing and ISC. But I don't yet see a systematic way to, you know, apply these principles. What this white paper is about is that, well, it's identifying the possibility that existing HPC centers can be used for this type of processing without a static allocation, without a static reservation of the resources. Now, if the static allocation is there, and I brought up the examples of PRACE and the Riken Japanese supercomputing center, then you can achieve marvelous results. Okay, there are point technologies as well, like managing sets of simulations, creating workflows that are very relevant to the situation. But again, I don't see them being considered in, let's say, in the manner that I presented today. Again, very kind of biased opinion probably, but there are some indications about that. I don't know if this is, what would be your reaction to this type of response?
No, this is, of course, this is, it's fine. So are there any more comments from Mark or Hans Christian or Dirk?
Please go ahead.
Well, maybe I can comment on that. I don't think that it's the resource allocation being, say, the biggest problem. I mean, we have seen now in the context of the pandemic, and you rightly pointed out, for instance, in this in the praise context, where it was possible to get on a relatively short time frame an agreement from, I mean, at the end, it's the funding agencies which have to define it, which sponsors the resources, to agree, okay, I mean, we should make, say, resources available for this purpose, and then to have an organization like PRAISE to actually work on then distributing these resources according to an excellence-driven access model. So I think if we would have the case also for urgent computing, I think that could also be done. I think that the problems are rather more in what you described also in the white paper, in terms of making resources available in a way that they can actually be used for urgent decision making. And that's where we talk then about, say, this question about, okay, how can then the actual, when the resources are allocated, how can they be made available sufficiently fast so that you can make an urgent decision? How can you provide, say, all kinds of stakeholders which are then involved in an urgent decision? It's not just, say, a small team of HPC people, access to, for instance, also the data which are being produced. So there are a lot of the technical challenges which needs to be done. And then, of course, there are also some policy decisions which need to be done. But I think it's primarily also the technical challenges which have to be then overcome and then be implemented so that they become operational.
Thank you.
Yeah, I can add also that that there is still the notion of well, let's say fast urgent and urgent, in the sense that for the pandemic we had a response time of several weeks or months, so that we could use the existing infrastructure and give priority and things like that, because the time frame is okay. Of course, the faster the better, but it's not let's say fast urgent or really urgent. When it's more very urgent, it's still dedicated infrastructure that are here, like for the tsunami detection or for the earthquake and things like that. So we still not have these two words that's converge yet. And we see also that now the HPC is opening to more processing data, or here in the ETP we are promoting the Transcontinuum initiative. That is how we could continuously process data, and it's also one of the goals of Destination Earth. But this is slowly moving. So I said that indeed the pandemic was the first step, but there are still a lot of steps that need to be done. And here also it's a continuum, because between urgent and real time, because at the opposite, you could see that you could have a real-time simulation or HPC in the loop to control very heavy simulation, like for example for fusion, where you need really to have in line with real-time, let's say, a decision. So here it's still on dedicated hardware. So here also we have a continuum, and what we propose here to push for urgent decision making is a first step to open the HPC community to this new requirement. So with all what Manolis explained, with well, if you open it, you will have to get data from the outside with the problem of cybersecurity. You will have to make a dynamic orchestration of the resources, not only batch job and things like that. And also now the HPC machine are heterogeneous with a GPU a partition, and it's not always easy to move a code dynamically from a partition that evolves. So a lot of problems need to be done, but this could be the first step towards more real-time, let's say, thing. And it's also in the mode, because we see that, for example, NVIDIA is making their OVX architecture, which is some kind of HPC machine, but for real-time simulations. So things are slowly moving in this direction, I think.
this is very interesting what you say, Mark. And so what I feel is that many of the bricks of the technological challenges you face are not only useful for urgent computing, but would also be useful for other situations or other use cases or other applications in HPC. So Manolis, for example, mentioned the point of checkpointing, which is, I think, relevant, even new methods for checkpointing. I think this is even relevant beyond urgent computing. And Dirk mentioned the infrastructure and the federation. I think these are also topics which are relevant for urgent computing, but also beyond urgent computing. Would you agree on this?
From my side, yes, and we are just trying to see what we have, how we can use it in this more challenging context. And in the process, many of the underlying technologies might be improved. This is my, let's say, view of this situation. It's not, let's say, something that is exotic, something that relies on technology that is very far out in the future. It's a better integration of what we have and trying to also identify and eventually solve challenges that are not only technical, but also organizational. Okay. If we accept that the boundary of the center, of the HPC center, is a bit more fluid, then this carries natural consequences for the technologies as well. And for the low-level technologies, well, yes, we already know that checkpoint is very, very hard if we have full state capture, okay? And now we are saying, well, we need to do that. And by the way, we need to do it fast and on large portions of an installation, of a facility. So we are pushing the boundary in some sense. And by the way, the file systems, well, we know that they can be challenged by intense checkpointing activities. So we are now saying, well, be prepared for very, very intense use of these storage resources, and likewise the interconnects leading to these resources. So I'm just highlighting the paths that are a bit more stressed now, but we need to start with the initial assumption. Are we going to do it with static allocation, which has quite a few advantages, by the way, if we can afford it, right? Or are we going to do it in this way that we're trying to expose today? I think there was also a comment in a question about static versus dynamic in the QA part of our session. That was about this static versus dynamic aspect.
Yes, absolutely. So
about the storage aspect.
Yeah, about regarding status versus dynamic resource assignment. It's a question from Sabri. He asks how data storage resources are managed and what is the implication probably of the data storage resource management if we change from a more static to a more dynamic resource management.
I mean, I can offer a first opinion on that, and perhaps the other panelists can add to that. Well, to do the processing, we need to have the data locally. This is pretty much how we operate. Now, if the data is coming from the outside, it's not directly on our file system resources. So we need to use some sort of data management facility, some sort of data archive, schedule a transfer, have this type of data set caching facility in place, and then operate on top of that. So again, the building blocks are there. The flow is now a bit more challenging because there is now a more obvious time constraint. It's not just, okay, I'm staging the data in, it will take me a week, okay? And then I will be running my regular, I don't know, physics codes and get some insight of the data and likewise produce my visualizations and my other scientific outcomes. Now we are asked to display trends to identify possible avenues of addressing a situation. So there is a more direct impact on of what we are processing. So we need to improve this path of bringing data in, and I think that's a challenge on its own, right? Even without the computation aspect. I don't know my colleagues on the panel how they would augment this response.
No, what you said is absolutely right, I think. So it stresses, well, the knobs and the mechanisms are there in principle, but we're talking about HPC, so we really need very high bandwidth and low latencies to data storage. And that really makes things more difficult than they are or might be, for instance, in more general enterprise computing applications, for instance. And there might even be, so you mentioned checkpointing as one way to save state of an ongoing computation. And it might even be worthwhile to look into more advanced concepts, like, for instance, having non-volatile memory on the compute node. So you wouldn't need to actually go out to a data storage facility. And if you take that thought further, you could also think about, would it be possible to make the network infrastructure that we're using, say InfiniBand and similar devices, able to keep the state that an application has achieved when another application is active? And it all depends on how expensive this is in research and development and capital and energy, whether it will ever catch on. But this would be an interesting research direction to look into.
So there are also innovation in terms of hardware to manage data. So now we have the DPU, that's the NVIDIA name, or IPU, so the infrastructure processing unit from Intel, which are not yet in the mainstream HPC, but allow to manage, also to make on-the-fly security check of the data and offload the processor of all the data management. And here we could have also storage, which is more and more intelligent. So now we will have really not only the CPU, but the CPU will be more an orchestrator with accelerator for the data management. So we already have accelerator for the matrix, let's say, tensor operation done by GPU. So here we will see an evolution where it's not only compute, but also data processing that are becoming more and more important. And this is closely linked with the bandwidth and with the storage. And indeed with non-volatile storage that could be near the processor or nearer the processor, that could bring a lot of innovation in the architecture and of the use of HPC.
Thank you. Thank you very much for this answer. So I think we are almost at the time. Is there one question? Hold on, give me a second. We have a question from Fabrizio Magugliani. He's asking, a problem to address is not only how to bring data in, but also how to communicate the output of the analysis to people, organizations, and to act upon these analyses. Is this more about what is the consequence, or what is looks like it's not really what is the, it's more an organization?
No, I think Fabrizio brings up here a very important point. I think we run a bit of risk when we discuss about this topic through basically our HPC view, that we think so quickly about it's moving about a lot of data. In many of the use cases which I have seen, actually, it's not necessarily about moving so much data. I mean, of course, there might be simulations then within the HPC system where you generate a lot of data, where you have to have all the fast data transport capabilities. But when it comes into data injection into the HPC system and the data egression or the access then to the results, that may be not very large amounts of data, but there it's where it becomes, in particular, when it comes down to access of the output of this data, it becomes very important to have, say, a very flexibility and to have then a lot of different stakeholders being there. I mean, think about catastrophic situations and that then, say, fire brigades or other security departments in a geographically largely distributed area might want to have access to particular pieces of this data. It's not necessarily about big pieces of data, but they have to have the access there. And that's, I think, where we have still one of the more biggest challenges of how to facilitate that.
Yeah. Well, and on top of that, of course, if you think about the really urgent computing, like Marcus told it, like, for instance, there's a wildfire out of control. So while the firemen are not going to look at a 3D simulation and visualization, they need information well, created or harvested from the data that we produce. And that step is a very interesting one, and probably not one that HPC can contribute much to, because it's more like, how do you do an analysis and what's the right human factor? Well, how do you do a human factor analysis, and how do you really derive actionable alternatives from the data that the HPC systems provide? That will be an interesting journey.
Mm-hmm.
So thank you very much. I would close with one question, because you mentioned obviously there are the technical aspects, but there are also the organizational aspects. And now we have a whole bunch of new machines arriving from the Euro HPC procurements. So do you think we will see the Euro HPC machines ready for providing this kind of computing resources? Do you think there are things to be set up, organizational measures perhaps to be taken to support this kind of computation?
Right. My view is that some of the aspects that I outlined today, for example, the federation aspect, I think we might see that. I think it's a challenge on its own, but I would say it's more organizational and policy driven. The lower level stuff, there will be progress, I think, in the time frame of the machines that are coming up. Very faster interconnects, faster processors, more heterogeneous systems actually, perhaps non-volatile memories available more broadly. So I would say that the total decision-making framework, I would say it has to be a policy decision. If we want to make it, we will try to start going for that. But I think we are putting essential pieces of the puzzle together. That's again my view of that. I don't know, Dirk, Hans Christian, and Mark might add to that.
I mean, I largely agree. I mean, there's a lot of, it's largely also about policies, but it's also about having, say, particular use cases driving this. And therefore, I would look at it from, say, this question about Euro HPC, not so much about will it happen. I would rather look at it from, now it's a great opportunity that you have basically an organization which has a responsibility for, say, a broader number of, say, systems, and which could really drive this process. So I think it's a unique opportunity. I would really hope that Euro HPC will take up that and drive it as a vision for HPC in Europe.
Mm-hmm.
So
yeah,
perhaps
we can a new community joining, like the community of artificial intelligence, which is more using to have interactive session than batch job. So now we have mixed partition, interactive, on batch. So that could be also a step that could go slowly towards having systems that are more ready for this kind of urgent decision making.
So what I understand is not everything is ready, but perhaps we have very good basis and very good stepping stones, and perhaps we have an opportunity here with the new HPC systems, Euro HPC systems, to engage in this direction. I think we could use this as a concluding remark, if I may say like this. So thank you very much for all of you for being here today and for contributing to this webinar. Thank you to our participants for taking part and for listening in. Just as a teaser, so our next webinar will be on June the 10th. It will be on a different topic. It will be on collaborations between industry and academia, which is often mentioned as a very good way of supporting innovation and of bringing research outcome quickly to the market. But these kind of collaborations are not always this easy. So here we will have partners from Onera and from Airbus and from DLR presenting their collaboration, which is ongoing for many years now. And they will share with us what their challenges are and how they manage to get a good collaboration going. So thank you very much for you being here today, and hope to see you then on June 10th, and wishing you an excellent Friday and very soon an excellent weekend. Thank you very much. Thank you.
Thank you, Mike.
Bye. Thank you.
Thank you. Take care.
Thank
Bye.
you.
Bye.
Bye.
Everybody.